Chapter 4, Section 3 is subtracting rational numbers, and I think you're going to find this lesson is very, very similar to the last lesson we did where we're adding rational numbers. Probably virtually identical, only there's going to be a minus sign instead of a plus sign in all of your problems. The content objective says students will demonstrate understanding of subtraction of rational numbers is adding the additive inverse and apply it to solving real-world problems. Suggested pacing says this is a one-day lesson, so buckle up and let's get busy. We're going to blow through this thing so you have homework to do at the end of this lesson today. One of the largest temperature variations in a single day was during the winter of 1972 in Montana. The temperature rose from a negative 47 degrees Celsius to a positive 9.4 degrees Celsius. If you converted that to Fahrenheit, that meant that there was a change of over 100 degrees temperature in a single 24-hour period. Now, we're not used to hearing Celsius, so let's find out what Siri says Celsius, that the temperature would be in Fahrenheit. Negative 47.8 degrees Celsius converted to Fahrenheit. She says that's a negative 54 degrees Fahrenheit. Why would you live someplace that gets to be negative 54 degrees Fahrenheit? I don't understand. People in Russia are sent to Siberia where it's like that as a punishment, and yet people choose to live in Montana. It makes no sense to me. Our talk about it says, how do you think you can find the change in temperature? These are the things we're going to learn in today's lesson. And now we get to watch a video from the textbook on subtracting rational numbers. Take a look and see what they say to do.
To subtract rational numbers in different forms, write the numbers in the same form. One way to subtract a decimal from a mixed number is to write the mixed number as a decimal. This method works if the mixed number can be written as a terminating decimal. Next, find the difference. To subtract the decimals, rewrite the subtraction as addition and add its additive inverse. Follow the rules for adding negative decimals.
Just subtract.
Another way to subtract rational numbers in different forms is to write the decimal as a fraction or mixed number. Use this method when the fraction or mixed number cannot be written as a terminating decimal. If the fractions have different denominators, rewrite one or both fractions using a common denominator. To rewrite a fraction, multiply its numerator and denominator by the same number. Next, subtract the fractions or mixed numbers. Sometimes when you subtract mixed numbers, the fraction in the first mixed number is less than the fraction in the second mixed number. In this case, rename the first fraction in order to subtract. Then, rewrite the subtraction as addition.
Now I want to stop and look at what they did right there because I want to make sure you understood. Right here they had 4 and 9/15. They changed that to 3 and 15/15. That's going to be your 4 because 15/15 is 1, 1 plus 3 is 4, and your 9/15 is right here. Next, 15 plus 9 is 24. That's where they got the 24/15 from. They are working this problem as a mixed number. We've talked about it's usually better to work them as an improper fraction, and they're showing you why it gets to be kind of a Herculean effort when you work them as a mixed number. Let's finish their lesson.
And add the additive inverse. Finally, simplify the difference if necessary.
That's all there is to it, but that was an awful lot real quick, so let's take a look at some problems on our own. The problem they give us to start off with is subtracting two decimals, and actually it's adding, but we'll talk about that. And they want us to start off by making a estimate. So right here we've got negative 3.27 minus a negative 6.7. So we're going to add, make an estimate first, and my estimate's going to be, well, first off, I'm going to say negative 3.67. That's about 3. Negative 6.7, that's going to be about a negative 7. And then I'm going to recognize that right here I have a negative times a negative, which is a positive. So I'm going to basically have minus 3 plus 7, which is going to give me a difference of 4. That might or might not be what they picked, but that's what I'm going to pick as my rough estimate. When you're dealing with estimation, what one person gets may not be what the other person gets, but as long as you're both close, you're going to be good. Now let's look at what they did here. They actually made the ugly problem pretty in this one, and they did it kind of like I did, only they chose for their estimation, they said that the 6.7 was closer to 6. I said it was closer to 7, but we're close on that. Then they made their ugly problem pretty. Negative times a negative is a positive. Then they said signs are different. Find the difference just like I did. Only difference is they came up with a 3 instead of a 4 because I rounded that to 7. They decided to go to 6. When they worked the problem using decimal versions of it, once again, they made the ugly problem pretty. Negative times a negative became a positive. Signs are different. Find the difference with the sign in front of the larger number going in front of the answer. So their final answer was going to be a positive 3 43/100ths. And yep, I'm not worried about what they're saying down there. This is some pretty good supporting work though. Something like this for solving your problem, that's exactly what I'm going to be looking for on your homework tonight. Now it's going to be your turn. Pause the video and solve this problem. 3 58/100ths minus a negative 2 9/10. Go ahead and do it now. Did you get it done? Let's see what I'm going to do. So I'm going to start off by taking my ugly problem and get my pen working. I'm going to make my ugly problem pretty. A negative times a negative is a positive. So that's actually 3 58/100ths plus 2.9. Next, I'm going to line my decimals off to the side. I'm going to separate this from my supporting work I had there and come off to the side, aligning my decimals just like I've already learned to do involving adding and subtracting decimals. Add it up, that's going to become an 8, that's going to become a 14, carry a 1. So my answer is going to be 6.48, which is going to be positive. Come back to where they have their problem and type it in, 6.48. Check our answer, and the answer checks. Very easy to do. Just got to remember the rules for decimals and the rules for integers. But what if you had a problem involving mixed numbers like this one? Now you can work these like they did in their video if you're really careful, but you're very likely to make a mistake that way. Or you can work them using improper fractions, which is the way I would do it. Let's see what they chose to do for this one. They chose to do improper fractions. So they said 3 times 5 is 15 plus 1 is 16/3, and then 9 times 4 is 36 plus 5 is 41/9. Next thing they're going to do is find their common denominator of 9, which means 16/3 changed to be 48/9, and then hopefully they're going to make the ugly problem pretty, which they did. They said a negative times a negative is a positive, making the ugly problem pretty. From there, 48 plus 41 is going to be 89/9, and you're going to take that, change it back into a mixed number, 9 8/9. I've got no complaints about how they show their supporting work on there. That is exactly what I would have done when I did it. Of course, you need to take and put your final answer right there, just like they did, so it will be in your notes. And now it's going to be your turn to solve a problem. Do this one on your own, plug in your answer, and see if you get it right. So did you get it right? Let's see how I'm going to work the problem. I'm going to start off by changing my mixed number into an improper fraction, which can be negative 1/2 minus, do my Texas approach, 5 times 2 is 10, plus 2 is 12/5. Next, I'm going to find my least common denominator. My least common denominator is going to be 10, so I'm going to set up my problem for that. 2 goes into 10 5 times. 1 times 5 is 5. 5 goes into 10 2 times. 2 times 12 is 24. From here, I've got my common denominator, so I need to focus on my numerators and my signs. My signs are the same, so I'm going to find the sum. The sum of 5 and 24 is going to be 29 over 10, and the sign in front of your larger number goes in front of your answer, giving me negative 29 over 10. That is an improper fraction. We're going to make our improper fraction back into a mixed number, which is going to be negative 2 and 9/10, and you should be able to do that one in your head. Easy math, or the 2 and 9/10 part in your head, I should say. Easy math, if you know how to divide and subtract fractions, and you know how to work with your positive and negative numbers, this lesson should be a piece of cake for you. Of course, we do need to check it. So, it should be a negative 2 fraction 9 over 10, accept and check, and our answer checks. Let's see what else they have for us. Ooh, look at this shiny problem. Here they got variables, y minus x, if x is a negative 2 and 4/10, and y, 4/5, and y is 1.4. This one involves mixed numbers and decimals, and we're going to have to decide, do we want to work them as a decimal, or do we want to work them as fractions? So moving forward, we're going to start off by taking that x minus y that they gave us, and we're going to substitute in the values that go with it. So x was negative 2 and 4/5, you see right here. Y was going to be 1.4 that you see right there. And now, because that denominator is a 5, we know that can be written as a terminating decimal. And just a real quick, we're going to go back over here and I'm going to show you what's going to happen on that. So we had, let's get some clean slate, a 2 and 4/5. Well, 4/5 I could multiply by 2 over 2, and that would give me 2 and 8/10. And that is the same thing. 2 is 8/10 is the same thing as 2 and 8/10 written as a decimal. So that is how we get the number we're going to put in right here, which as a decimal is going to be 2.8, except that. And then from here, they took, and I don't know why they're doing this. They're doing an additive inverse. Just subtract the dog, okay? But with theirs, what you're going to want to put in is a negative 1.4, which why they're making the problem more complicated, I don't know. I would have taken and stopped right here. Oh, hold on. I screwed something up on that one. That should be a negative 2.8. There, it makes more sense. I would have gone from this point right here, said signs are the same, find the sum, which is 4.2. Sign in front of your larger number, goes in front of your answer, giving you negative 4.2. They want to make it more complicated. There's no reason for you to do that. Now we can solve this same problem using it as a fraction. With a fraction, they did the same exact thing initially. They started off by converting the x and y to be negative 2 and 4/5 and 1.4. Then that 1.4, well, that's the same thing as saying 1 and 4/10, and 4/10 simplifies down to be 2/5. That's where they got the 2/5 here. Now you got your common denominator. Question is, are they going to work it as a mixed number, or are they going to use an improper fraction to solve it? When they did it, they went ahead and changed improper fractions. 5 times 2 is 10. 10 plus 4 is 14. Give them a negative 14 over 5. 5 times 1 is 5, plus 2 is 7. Give them a negative 7/5. Signs are the same. Find the sum. Don't do this step. No reason to do it. Find the sum. The sum of 14 and 7 is 21 over 5. Sign in front of your larger number goes in front of your answer, giving you negative 21 over 5, also known as negative 4 and 1/5, which is what you would take and type in right there for your notes. Two different ways to skin that cat. We could change it to a decimal this time because it did give us a terminating decimal. And now it's going to be your turn to solve this problem, a minus b, where a is 1.6 and b is 7/10, You can figure out which way you want to solve it. Do you want to solve it as a decimal, or do you want to solve it as a fraction? In this case, both are possibilities because your fraction has 10 in the denominator. That's 2 and 5. 2 times 5, as long as your bottom factors are 2's and 5's, you can change it into a terminating decimal. Pause the video and solve it. Did you get it done? Let's see how I'm going to do it. My A value is negative 1.6, minus my B value is 7 over tenths, 7 tenths. Now that 7 tenths, I'm going to rewrite it as a decimal just like it says because that's super easy to do. Negative 1.6 minus 7 tenths, 0 and 7 tenths. Now I have signs are the same. Find the sum. The sum of 1.6 and 7 is going to be 2.3 with the sign in front of your larger number going in front of your answer, giving you a negative 2.3. I'm going to come over here, type that answer in, negative 2.3, accept, and check it, and our answer checks. Easy math. Anybody can do this stuff. That was a quick, skinny lesson. It's time for y'all to start your homework, and you only had to watch one video this time. Good job.